So hello, I'm Sean Hancox from Messology, and I'm here with Jonathan, aka DJ Ignio, who has created, who is the creator of LR9K 9000. And I got in touch with him a couple of months ago when I was trying to figure out some of the details of his plugin, which works with DAZ Studio. I was blown away at how quickly I could create really good lines and line art drawings from some of the DAZ renders that I was doing, and I wanted to know more. So, hi Jonathan.
Hi Sean, thanks for having me.
Thanks for coming along. So I guess one of the first questions I'm interested in knowing is why did you create LR9K 9000?
Well, to put it simply, I created LR9K 9000 because I was having difficulty getting good lines from 3D objects. So, as many others probably have, I've been interested in making cel-shaded style art for a graphic novel or a comic book, and I already knew DAZ Studio, so I wanted to try and get cartoon looks out of DAZ Studio. Since I was unable to find any products in the DAZ store that allowed me to do that, I ended up making my own.
Well, I gotta say, it's a great plugin. It's saved me hours of time when I found it.
Glad to hear it. Should we go through some of the deeper features of the product?
Yeah, I think that'd be a great idea. So the one thing I want to point out in this tutorial is that as we started, LR9K 9000 has a huge number of uses and ways that it can be used. And in this particular tutorial, we're going to be focusing on a basic understanding of how the product works, how you can tweak it, how you can get images out of renders that you maybe thought you couldn't get before. And we're going to avoid products that have transparency maps, and there's a reason for that, and perhaps Jonathan can explain that. But ultimately, we will be covering transparency maps, but we will cover it in a separate episode, a next episode, if you will.
Right. So one of the problems with trying to get good outlines when dealing with transparency is whenever there's a partial transparency, especially when the partial transparency is used to approximate something that's not really partially transparent. So if you take, for example, hair, oftentimes the designers of 3D, well, from back in the day, they developed all sorts of shortcuts where the hair isn't strand based, instead it's a full mesh, and then the transparency simulates sort of the partial see-through that you can that happens when light passes through the hair because it's a bunch of different strands. So that can end up being a little complicated, so we're not going to talk about that right away.
All right. So the next thing that I want to mention is that one thing that I learned about trying to create a graphic novel kind of a look for anything that comes out of LR9K 9000 is that resolution is first and foremost. And I know this because I have a print background, and anything that you print needs to be at least a resolution of 300 dpi. Anything less than that, I mean, we're so used to looking at stuff on our phones now and computer monitors that people don't think about dots per inch. But in reality, in print resolution, if you don't have at least 300 dots per inch, and in some magazines it needs to be at least 600 dots per inch, especially the really high quality, like coffee table books. If you don't have that kind of a resolution, whatever you print, if your ultimate end game is to print your graphic novel, it's going to look jagged. You're going to get all these jagged edges on it. So we're kind of limited by DAZ Studio in that DAZ Studio doesn't allow you to change the resolution, so we have to do a bit of a workaround. In DAZ Studio, any image that it renders out will be at 96 dpi. So if you're rendering out for print at 300 dpi, you take 300 divided by 96, which gives you a scale factor of 3.125. Then, using this as an example, if your final image was 4 inches square, you'd multiply 4 times 300, the resolution you need, times the scale factor from above. So in this case, you'd have 4 times 300 times 3.125, giving you a render image size of 3,750 pixels that you would need to specify before you render out. If you're only rendering out for screen use, then pick something that looks good on your screen and it'll be fine. If you're rendering out for print use, you have to up your resolution. And typically for me, when I render anything out for comic book use, since I don't know where it's going to end up, for example, I might sell a comic and somebody might want to print it out on their own printer, or maybe it's a really high quality printer. Maybe they're going to print it out at 600 dpi. You never know. I always render out at the highest quality dpi that I can, just because. However, rendering out at a higher resolution comes at a cost, and in this case, the cost is size of the file and the time that it takes to render. So I just want to point that out before we start.
Yeah, all very good points, Sean. One of the other things that matters for specifically to Line Render 9000 is that the lines are going to stay constant in their thickness regardless of the output size of the image. So it's important to stick with one size so that way your line thicknesses are going to be proportionally correct to the size of your image.
Oh, good point. I hadn't thought of that. All right.
So it's also worth mentioning that there's a upper limit in 3D Light for how big it will draw the lines in pixels, and that's 11. So it won't allow you to draw lines that are any thicker than 11. Thankfully, that's probably big enough for most print applications.
Okay, that's good. That's great to know. So let's get to some demos. So what I have loaded on my screen here are 3 primitives. I've loaded nothing else. There's no maps on any of them. Cube, obviously a sphere and a cone. They're intersecting each other. Haven't loaded LR9K or Line Render 9000. So I guess the first thing I'm going to do is load that up and take a look at some of the settings in Line Render 9000. So I'm going to start with the black and white cameras. I'm just going to double click the script, and you can see right over here in my scene settings, it added a Fresnel camera reflected, LR9K black and white, LR9 camera composite camera, shadow opacity cam, tune two-tone cam, and a main camera. So those are all added automatically by the script. But just before we get into changing the Line Render 9000 settings to tweak your image to give you a better final product, I thought it would be worthwhile showing you from our rehearsal what happens if you don't change any of the settings right off the bat. So that's why I have a slightly different setup of the primitives in my window here. I wanted to show you what it looks like. When we go ahead and render it without changing what Jonathan is about to tell us how to change, the render of these 3 images, the line art, I should say, of these 3 images ends up looking like this on the screen. So let's get back to the tutorial, and Jonathan will walk us through what we need to change to make it look much better.
Okay, great. Well, let's start by setting our color IDs on all 3 objects. So to do that, we'll select the cone, which we already have selected, and go down to the Surfaces pane and select the cone's surfaces.
Okay.
If we scroll all the way down to the bottom, we should find the LR9K color ID property. And there it is. No, that's
color
it's not there. Yep. In order to get the color ID property, if it's not showing like this, the easiest way is to go to Render Settings tab over on the left and change the engine to Scripted 3D Light, and then select the Line Render 9000 render script.
Gotcha.
The Line Render 9000 render script is set so that when it loads, it's automatically going to add this property, this new Line Render 9000 color ID property to all the surfaces in the scene. So at this point, if we scroll down, we should now see the LR9K color ID property. And we do, it's currently set to white. Yep, so let's pick some nice easy colors for these three objects. So perhaps let's set this one to red, and then we'll set the sphere to blue and the cube to green. Nice big primary colors.
Sorry, need to click on OK, not go away. Okay, and the sphere to, what did you say? Green. Green it is. And blue. Okay, so what exactly are you doing with the color IDs?
Well, as you may note, it hasn't actually changed the color of the objects in the viewport or in the scene. What line render does is, under certain circumstances, at render time, it will swap out the materials that are on the object for more or less an empty material, setting it to the color that's specified in the color ID. We could see that simply by going to the properties over in our render script, over in the render settings tab, going to line render 9000, and turning on the option for use color ID materials.
Okay.
And now if we click render right now, we'll see the output of this option.
All right. Red, green, and...
Okay, so, yep. So there's a property on the render script that will more or less substitute the colors of the different objects in the scene with the colors that are the LR9K color ID values.
Okay. So we go back to here. Auto render?
Yep, let's go ahead and kick off the LR9K auto render script.
All right.
All right, so the first thing we should do here is disable the composite passes options down at the bottom. So down in the bottom half of the screen where it says composite settings, we uncheck the enabled button like you did, the enabled checkbox. And the other settings up at the top, let's just take a look through them real quick. So the first one is set to render out with a tuned two-tone camera using the 3D Light rendering engine. Then there's a couple more renders afterward. There's the main camera once again, except for this one, if you look in the properties, it uses the color ID materials. So render pass number 2 here is going to do the same render that we just did.
Okay.
But now that it's using the line render 9000 script, it's also going to generate outlines. And we'll get to what that ends up looking like here in a minute. The third render pass is the Fresnel reflected V, and that's going to more or less create our detail lines. So you can see that there we have the color ID materials turned off, although we could certainly turn it on here. And then the last one is shadows, which we don't need for this experiment. Let's disable the shadow opacity cam for the time being.
Yep.
And we'll need to type in our file prefix, and then we can let this one rip and come back in a minute when the render's done.
First render, and I'm going to change this from TIFF to a PNG.
Sounds good.
And we're going to say render.
Yep.
And done. Use Photoshop here. I'll bring one in. And then we'll drop the others on top of it. Like so. And they get brought in as smart filtered items. So if we look at them in Photoshop, there is the was that the two-tone? It never names the first one when you drop it in. It's the two-tone camera. There's the first one. Second one is the main camera lines. You can see them. I can put a layer in here that has white background. So it's a little bit easier to see.
Yep, great.
And the Fresnel lines and outline. So that's what we got.
Great. Okay. So let's dissect what the line render script just did for us. What it did is a series of renders back to back, with the ones that were the line render 9000 render script generated two files, one for the main render and one for the lines as well. So in our 3 passes, we ended up with 5 total images. One for the two-tone camera,
Yeah.
2 for the color ID render,
Yeah,
and then
those two.
2 for the Fresnel reflected V's.
And those ones.
Exactly. So what the line render 9000 script does is it will draw lines based on the differences in color of the output image. So if we take, for example, the color ID render with the main colors shown, if you don't mind activating that one, and then if we turn on the main camera lines, we can kind of see the output of that render, so to speak, in the lines.
Yep.
So yeah, turn on, yep, this one. So here we can see that we've got a thin outline around all of the objects, and we also have very distinct outlines between each one of the objects. The reason for this, or the reason why the lines are so clean looking, is because the colors between the different objects are very distinct from one another. Now, this isn't how it normally happens in an artistic scene. Colors end up blending together, and there's not very clear delineations between what's one object and what's another object. So one of the hurdles that needs to be overcome when trying to generate lines from 3D objects is to get a clear delineation between what's object A and what's object B. So that way you can get clear lines around object A and object B separately. So the rationale behind using the color ID feature is to be able to identify the different objects based on them being distinctively different colors one from another, while also not modifying your whole image so that it's married to those colors. You can still have your regular render in the original colors or the original textures that you were using for your scene.
That's great. That's brilliant. So basically what you're saying is that in the case of, I don't know, let's say a shirt that somebody is wearing where it starts to, like if their hands are down at their sides and the shadows start to creep into where the arms are down at their sides. If you changed, like if the shirt was made in so that the arms were separate from the body, you could actually change the arms to be a different color ID from the body of the shirt, and so that when you rendered it, it would ignore the shadow passes, but you would get the outlines of the arms beside the body.
That's correct. And in fact, most of the technology that's being used in Line Render 9000 is trying to get to the geometry of the objects without caring too much about the textures or the lighting of the objects in the scene. Because most of the time, lines are being derived from the curvature of the 3D objects themselves, and the lighting and the shadows and things are sort of adding additional detail. So if we take, for example, the Fresnel reflected V render, we may note that it's entirely black and white. It's in a grayscale type of image. And this is another one of the simplifications that line render makes in order to get better lines. The Fresnel view is effectively a geometry only view. We're not getting light that's being shown based on the lighting of the scene. It's just a kind of a default lighting, so to speak, that's applied to the image. And it's completely in grayscale, so that way the outliner that's built into 3D light doesn't get too confused about where the line should be. So in the case of the cube, we may notice where we can expect to get very clear lines, and that's between the black that's on the face of this cube in comparison to the edges that go off into the Z-plane behind. You can see that those are kind of a lighter gray, whereas the front of the cube that's facing us is completely black. We might also expect to get a line, perhaps, or some lines on the cone, sort of, where it makes a triangle at the top of black and goes down. Maybe we take a look at the Fresnel lines without the render behind it, just on a white screen, and we can see what we end up with. So yeah, we can see that where the strongest line is indeed where I pointed out, where the front face of the cube, which was in complete black, it contrasted to the lighter gray of the cube. That gives us the strongest edge.
Yeah.
And then it looks like the rest of them are lines separating between the different objects in the scene.
Yeah. Interesting.
So if we were to make a cartoon render out of this scene, what we would probably do is just use the line outputs of the two other images. So we would use the layer 1 in our case, which is the two-tone camera with the camera lines and the Fresnel reflected V lines. And then we start getting line work that is complementary to the main colors of the scene.
That looks great. And then what I started playing around with was adding the Fresnel, but mixing it at a different, like a lighten, like so. And I mean, you can run.
There's a lot of different.
Yeah, you can run.
There's
through
a lot of different
mixing
effects that you can get from the intermediate renders that you get from the line render cameras. You can get a lot of very interesting and varied results from experimenting with those, which is one of the big things I see as an advantage of thinking about rendering artistically using tools like line render, where you're able to divide your scene up into multiple components and then reassemble them in whatever way you want, giving you a tremendous amount of strength in post as to in post work as far as what your final product ends up looking like.
Yeah. So let's load a scene and see what we can tweak with it. I prepared a scene using a product called Futuristic Laboratory. Open recent Futuristic Laboratory. So I just want to explain this scene a little bit first. So when this scene first loaded, it came with a bunch of presets. You can see 7 cameras here that I've all turned off. Inside the laboratory itself, there's a bunch of stuff that I turned off. And basically I just turned this off because it's small details that would extend the render time. For this particular tutorial, I wanted to render in a relatively realistic amount of time, or a short amount of time, I should say. And the smaller details weren't necessarily germane to the topic that we're talking about. I have no Line Render 9000 cameras loaded into the scene yet at all, and I have no cameras loaded into it. Now, the one thing I'm going to point out about this particular scene is that this is a small room. Like, You can see as I turn around, I actually go through the wall, so I have to zoom in a little bit to get back into the room. And I don't know if anybody has come up with this problem before, but I know that the best way to get around, dealing with smaller rooms, because usually if the walls are four walls, it's as in any television studio, you can turn off the fourth wall, which is why it's always called, he's talking to the fourth wall, right? The cameras all shoot through the fourth wall, but in this particular set, if we take a look at it, if I turn off the laboratory, the walls are gone. That's true, but all the walls are gone. Doors are still there, but the walls are gone. I could open the doors and move back through the doors, but that doesn't really help me much if I want to stay in this particular space. So the only way that you can stay in this space and get a wider view is to add a camera. So I'm going to create a camera. New camera. And we're going to call it, that's fine. And we're going to call it wide angle. Accept. So here's my wide angle camera. And the first thing that I'm going to do is I'm going to go down to the camera settings, which is here. I'm still on my wide angle camera. Focal length. I'm going to, it's not focal length, sorry. It is focal distance. Nope, not that one either. Width.
Don't forget to change your perspective to
oh, thank you.
use the new camera that you added.
That'll help. Thank you.
Mm-hmm.
So here we are, still in the same room, but I'm certainly seeing a lot more. And if I change my focal length, it should be, yeah, there we go. Now we're seeing almost that's the whole room. It's pretty ugly, but that's how you can work in a small space within DAZ in actually a quite realistic method. So I just thought I'd share that little tip with everybody.
It's also a great trick to learn how to do foreshortening, which is a technique often used in comic books and things. So experimenting a little bit with frame width and focal length is a great thing to learn how to do if you're planning on making graphic novels and that sort of thing using DAZ Studio.
Absolutely right. Yep. So this is the scene that we're going to work with. There's no people in it. All we're focusing on is trying to create some kind of a realistic render, or I shouldn't say realistic. We're trying to create a line art render for this particular scene. I've got a couple of views or screens in the background that are just basically maps. I got some kind of a control console here. I got a bed, a thing that's going to cut your arm off, and lights for it. And oh yeah, and if you move in a little bit, yeah, we got doors, and the doors do open and close, although we're not going to see anything on the outside because there's nothing out there. So that's the scene that we're working with right now. So
okay,
there we go. So I guess
okay, great. Let's pick an angle and start and render it out, and let's see what we're dealing with.
So this look good to you? You want me to back up a little bit? No?
Maybe go a little bit to the left.
Like so?
If we can. Yeah, I think that's good enough. Yeah, that's good.
All right. And
all right. So let's get rid of all those camera 1 through 7.
Yep.
And then let's load up the Line Render 9000 preset.
Let me just... And we'll do the Line Render 9000, the black and white again.
Yes.
So it brings in, as before, the Fresnel, the black and white camera, composite, shadow, two-tone, and main camera.
Yep. All right. So let's kick off the LR9K auto render script.
All right.
And set a couple of the things for our scene. So once again, we're going to disable the composite settings. The reason for this is because the composite cam was meant as a way of creating a very quick visualization of the art that you're getting, adding kind of a one-click option. But almost all the time I use external photo editing software. I use GIMP. I know you use Photoshop.
Yep.
So for this tutorial, we're going to continue to use Photoshop. In the top of the dialog, we need to enter a file prefix, and then we'll change our file type to PNG once again.
Yep.
All right. So let's go ahead and render this one out, and let's see what it does with default settings.
All right. Now it's worth pointing out at this point, I think, that it's not like the compositing these layers requires a transparency map, and PNG and TIFF both give you that, but JPEG does not, in case anybody's not familiar.
Yeah, that is correct. In fact, I was very reluctant to add the JPEG option, but it is indeed a supported output file type in DAZ Studio by default and in 3D Light, so I added it, even though it sort of doesn't make sense to use in conjunction with line render.
Yep. So we'll go ahead and render this. Now, earlier when I rendered this, I ended up with a, and you mentioned this before, some kind of an error, a 3D Light error or something like that. Watch, we're not going to get it now because we're doing it.
Nope. Bugs don't show up when you're next to the developer.
Nope. But if it happens to you, don't worry about it. And it renders incredibly quick, which is part of the great thing about this plugin, I think. Like imagine, like if you're
Right.
if you're creating a comic book, there's an average of 6 panels per page. Oh, there we go. There it is. Severity number 1. That's gone.
Yep.
So let's go back into Photoshop. I was just about to say though, if you are creating a comic book, you're doing an average of 6 renders, 6 renders per page. And typically, if it's a print book, it's 48 pages. That's a ton of renders to do. So if it's a slow render, I'm just going to put these in our. We started here. First render 3, two-tone V lines. Yeah, these ones are just going to put it in old stuff. So we start here, bring that one in, and then bring the other ones in. Alrighty, so then what we have here is this first one, which was the two-tone cam. I'm going to just rename that two-tone cam. So we have this one, and I'm going to add another white layer down here. So two-tone cam, main camera lines, main camera lines here. Main camera was the other one. Fresnel and opacity and outline. Oh, that one shouldn't have been in there.
All right. So we have a lot of interesting results, but I think that we can make them better. I mean, I kind of like the look of the two-tone cam. It has an interesting sort of cartoony look. What the two-tone cam does is it'll allow for combining some of the colors that are in the quote-unquote regular render together to kind of give it more of a cartoony look. So the colors get blended together, they get clamped. So that's what that one does, and we might be able to tweak that to get some better results from this render if we played with the camera settings.
All right.
But before we get to the color, I think it'd probably be good for us to dial in these outlines a little bit more, because right now the outlines are sort of a mess. If we take a look at the camera lines from the main render, if you don't mind, let's open that one up. Is there anything? No, we don't. Yeah,
Oh, yeah.
we do have some
Yeah.
lines
Yeah.
there. Okay, so it's just kind of fascinating result, because some things we have really, really nice outlines on, and other things we don't. Now, let's go take a look at the line render settings again inside of DAZ Studio, and let's see what that pass was doing for render pass
For the main
2.
camera?
For the yep, for main camera. All right, so on main camera, it's let's see here. So this pass is using the color ID materials. So if you remember back to when we did the example with the primitives, what the color ID materials checkbox does is at render time, it will swap out the colors in the scene with the colors that are in the color ID.
Right.
If we flip back to Photoshop and take a look at what that main render looked like, it should be pretty clear to us then what the outliner did and why. So go back to, sorry, not that one, go to the one right up from that, the main camera outline. So this is the output of the color ID pass. So what happened is most everything in the scene is all white, and then we have some cases where it's black, right?
Yeah.
And that's where we're getting the nice lines, is where the black on the gray, the black on the other gray, the white on the gray, those are giving us good lines. But the white on white and all of those are not giving us good lines at all.
Right.
So let's see if we can improve that output a little bit. So let's go back to DAZ Studio again, and let's see what we can do. Some objects seem fairly clear-cut to me. That center console and also the operating table, is that an operating table?
Yep. Yep.
Those two things, I think we can give different color IDs, and then let's see what that ends up looking like.
So grab the
So if we select the, yep, let's grab the machine, and yep, and now if we go to the colors,
Oh, surfaces. Oh, I am surfaces.
yeah. If you expand the nodes, there's LR9K color ID. If you expand the nodes under the surfaces pane, there will be a separate group for
I see what
Line
you're
Render
saying.
9000.
Yes.
Or you
There's
could
one.
enter in
Yep.
text to
There's one there.
up at the top. Yep.
There is. Yeah, there's a few. Oh, I didn't scroll down there. That was my mistake. Oh. Machine body has no color ID, it looks like. But this one does. Machine body 1 does. So change this to something else.
All of them are white.
Yeah. Red? Sound good to me.
Yep, but red should work fine.
And we'll pick maybe, I don't know, a blue. I guess it doesn't really make any difference what color we choose, does it?
Well, the only thing that makes a difference is that we choose a color that isn't going to create confusion with the colors that are right around it.
Okay.
So in our case, if you remember what the color render looked like, the color ID render looked like, the floor was kind of a lighter gray and the wall was a white.
Right.
So we need to pick colors that contrast with the gray floor and the white wall.
Okay. Well, I think those neon colors will. Should we?
Yep.
Should we try another
So
render?
then, Yes.
Or do you want to do the
Let's do
bed?
that.
Want to do the bed first?
Okay.
Okay, so they're all, I think, different colors. Should we
All
run
right.
another
So
render?
let's load up the auto render script again. And this time we'll disable the scripts or disable the render passes with the exception of the main camera pass.
Okay, so this
So disable,
one,
yep, 1,
and this
2,
one.
and 3.
Yep, so we're only going to do the main camera.
Right. So in this case, we're essentially just replacing the outline render.
Right? So that's done. Wow. So
Okay, let's
I
drop that into the Photoshop and see what it looks like.
this one is old. Oops. 5. So I didn't rename it something different, so this is here and here.
Yep.
And we're just going to drop them in on top. And then
That's fine.
I'm just going to move them down to where they belong so that it's easier for us to understand what's going on. So here's the first pass. Here's the second pass.
Right, so it looks like the console didn't get new colors. It's still white
No,
primarily.
looks like it's still white primarily. And then the next one, here was the first pass, and here was the next pass.
Right, so we can see how the second iteration with the lines gave us much better lines when it came to what do they call it, a bed?
Yeah, a sucker, a victim table. Okay. Wow, that's interesting. Okay.
All right, so back to Daz Studio, the next step would be to go through and choose different colors for the different things that we want to be outlined independently from each other. That way we get nice clear outlines for them. There is an easier way to do this, thankfully. After doing a lot of this manually, I ended up creating a script that will automatically assign color IDs to a selected group of objects.
Okay. Okay, so the scripts appear under where I have my content loaded, my content library, my DAZ 3D library scripts. We have 3 scripts. One is, come on, assign color IDs to each selected material, assign color IDs to selected objects, and assign unique color ID. And I'd just like to add that these scripts are included with this tutorial.
Yep. All right. So perhaps let's select the what's that object right to the right of the bed? What was that one
This
called
thing here?
again?
Machine.
What a great name. Okay, so then now that we have that selected, down under the machine body there, let's select the assign unique color ID to materials.
What's some materials? Okay.
I believe it's to each selected material. So if we double click that one, the expectation here is that we end up getting a LR9K color ID. And if we flip through the different materials here, I'm kind of expecting each one of them to have a different color ID from each other.
Yep.
Yep. So
And I'd just like to mention that another way to find the color IDs is to expand the materials of the model, which will reveal a group called Line Render 9000. And a quick way to work with the color IDs is to enter LR9K into the search box here, and it will show you just the color ID and what that current color is. You can also change the color from here, since basically it's just filtering the groups to show you only the LR9K shader node.
All right, so what other objects can we get? Let's see, those little cylinders that are at the edge of the door or at the far wall.
Here's,
What are those called? Oxygen tanks?
Yeah, oxygen tank 1 and 2 or 3 and 4.
All right, so maybe we select all of those and we can probably make them all the same color. So let's select all 3 of them or 4 of them.
4 of them, yeah.
Yep, and then, yeah, let's select all of the materials, and then let's assign color ID to the objects in this particular case.
Now these things are actually broken down into you can see here just by the way that the material zones work. The very top, the collar, and the body of it. So make them all the same color.
If you wanted to, if you want a clear outline around that part for like a distinct color, you could do that. I think they're far enough in the background that we're probably okay with just a single outline and having the main color render give us the difference in color between the top and the bottom.
All right, so should we assign it ourselves or let the script assign it?
I would let the script assign it if you have access to the scripts.
Yep, right here.
Yep, and it would be not that one, but the one to the right. Assign color IDs to each object.
Okay.
Yep.
Done.
All right.
Wow, that's easy. I love that.
Yeah, it's way easier than clicking it. All right, so are those lights different objects? The lights on the walls?
I don't think so. I was let's see, laboratory floor. It's the laboratory itself. Let's see. Oh, maybe you're right. LED floor. Monitor A, monitor B, light base, metal beam support, mounted monitor frame, outer wall, and rubber and screws. So I would guess probably, if I had to guess, well, we could assign, I guess, different things to everything.
Yep, so let's select all those and then just click our script for assign based on material, or assign different colors to each material.
All right.
All right. All right, I think we've done enough to do another render and see how that ends up coming out.
All right. Still just the one camera, the main tune camera, or the main two-tone camera?
Yep. Yep, until we get the outlines right. We're going to keep at it.
And we'll do the same thing. We'll bring it into Photoshop. Certainly psychedelic. Wow.
Yeah.
So that's that one. That's that one. So this one comes down to here. And line pass number 2 stays there. So, okay, so here's what we've got. So progressions are, that was the first render. The second render was this one.
Yeah,
third render
let's
is
just
that
look
one.
at the lines primarily.
All right. First render, second render, third render. Wow, they're getting, wow, look at all the detail that's coming out here. There's a lot of detail, and the floor is outstanding. The column on the right-hand side, the light fixtures themselves have come out, they popped. Wow.
Yep. So, okay, so we lost that little detail on the floor that we had before, the LEDs. Looks like.
Oh, yeah, I see. By coming...
Did we?
By combining the two, we've lost, okay, so we've gained, yeah, okay. So,
All right, so let's go identify what was causing that before. Or actually, no, sorry. Load up the, open up the psychedelic render, and let's take a look at that real quick.
okay.
It's quite possible that what we ended up with was two colors that are very, very similar to one another right next to each other. Yeah, so on the floor there, we can see that we've got like a slightly darker purple on top of
Yes,
like a magenta.
yeah.
So we're not getting a ton of contrast there in the floor, and that's probably why that happened. So for now, I think we're mostly fine here. Since the difference in colors are now distinct, we can really lower the decision making on 3 to light to say be more liberal with the way that you draw lines.
So at this point in our recording, we're going to break it into two parts. The first, obviously, what you've just seen, and the next we'll pick up at this point with a brief reminder of how we got to this point. As Jonathan mentioned, we're going to focus on refining our lines in the next part. See you then. Bye.